Hello there, welcome to CXC Math TV. Today we will be looking at solving equations using a matrix method. Really nice. So we can use matrices to solve simultaneous equations. For example, 4x minus 5y equal to negative 6 and 3x plus 2y equals 7. We know to solve this using other methods like substitution and elimination. Now, using matrices, the steps to solve are: number one, to solve a pair of simultaneous equations, we first need to rewrite the two equations in matrix form, that is in the form AX equal to B, where A is the coefficient matrix of X and Y, X is the matrix of the unknowns, and B is the result matrix. What do I mean by that? No worries. So look at this right here. Imagine if we had given the simultaneous equation in matrix form. So just imagine some brackets fly come around it, right? So 4x minus 5y equal negative 6. That's in the first row. Then the second row is 3x plus 2y equals 7. So that would imply if we're to break it up now as two separate matrices, the coefficient matrix would be the coefficient of the x is 4, the coefficient of the y negative 5, coefficient of the x 3, coefficient of the y 2. 4, negative 5, 3, 2. That's our coefficient matrix. xy, or next matrix, that's our unknown matrix, equal to negative 6, 7. We're going to call that our result matrix. So look at that. Our A is 4, negative 5, 3, 2. X is xy and B is negative 6, 7. And so AX is equal to B, where we have our A, X, and B. If you don't believe it, you can go ahead and multiply AX. And when you multiply the matrix A times X, you're going to get back the two simultaneous equations. Now that we have it in the form AX equal to B, we're trying to find X, right? We're trying to find X and Y. Now look at this. If we multiply both sides of the equations by 1 over A, 1 over A times A cancel each other. And so we're left back with 1 over A times B, that is X. So X is A inverse. 1 over A is A inverse times B. Now we know the matrix A, we know X and we know B. And X is what? XY. So all we need to do is find the inverse of A and then multiply it by the result matrix B, and then that is going to give us our unknown X and Y. So look at this. For the matrix A, we can find the inverse by saying the inverse of A is 1 over the determinant of A times the adjoint of A. That's 1 over 4 times 2 minus negative 5 times 3 times the adjoint of A, which would be 2, 5, negative 3, 4. Now the determinant works out to be 23, so it's 1 over 23 times 2, 5, negative 3, 4, which is 2 over 23, 5 over 23, negative 3 over 23, 4 over 23. But we said X is what? A inverse times B. And so XY is going to be A inverse multiplied by B. Then we go row by column. 2 over 23 times negative 6 plus 5 over 23 times 7. Then negative 3 over 23 times negative 6 plus 4 over 23 times 7. That simplifies to be 1, 2. So realize that xy is equal to 1, 2. Now by equating these two matrices, then the x must be equal to the 1 and the y must be equal to 2 by using equal matrix. And so you can go ahead and check it. Check it and see if x is 1 and 2 in the equation. 4 times 1 minus 5 times 2, that's 4 minus 10, which is negative 6. But that is the first equation, so it is true. Now check to see if when we put in 1 and 2 in the second equation, if we get 7. 3 times 1 plus 2 times 2, that's 3 plus 4, which is still 7. The equation is true. Nice. So just to summarize, first thing you need to do is to rewrite the equation in matrix form, AX equal to B, where A is your coefficient matrix, X is your matrix of your unknown, and B is the result matrix. Step 2 is to find the inverse of the matrix A. Then step 3, we need to solve for x and y using A inverse times B. So those are the 3 steps that we use to solve a matrix equation. Those are the 3 steps. So let's look at another example right here. Given the equation x minus y is negative 5 and 3x plus 2y is negative 5, write the equations in matrix form and then B, hence solve the equations. Now, let's start with part A. So pause the video and attempt and start with part A. So go ahead, and as we would have written this in matrix form, it is going to be the coefficient of x is 1, the coefficient of y is negative 1, coefficient of x there is 3, and the coefficient of y is 2. So that is 1, negative 1, 3, 2. Then our unknown matrix xy equal to the result matrix, and the result matrix in this case is 5, negative 5. So now we're just going to say, okay, ax is equal to b to do part 2, and then we know x is A inverse times b. Alright, so step 1 is out of the way. We already have it in the form ax equal to b. So step 2 now is to find the inverse. To find the inverse, we need the determinant and the adjoint. So the determinant is 1 times 2 minus 1 times 3, which works out to be 2 plus 3, which is 5. The adjoint of A is going to be interchange the leading diagonals, the 1 and the 2, so that put the 2 where the 1 is and the 1 where the 2 is. Multiply negative 1 times negative 1 and 3 times negative 1. So the adjoint of A is 2, 1, negative 3, 1. Cool. Once we do that, we already found the inverse now, because A inverse is 1 over the determinant times the adjoint. So that's 1 over 5 times the adjoint. That will simplify to be 2 over 5, 1 over 5, negative 3 over 5, 1 over 5. Then step 3 is we solve for x using A inverse times B. So we just found the inverse matrix. We're going to multiply that by the result matrix. And so we go row by column, 2 over 5 times 5 plus 1 over 5 times negative 5. Then we have negative 3 over 5 times 5 plus 1 over 5 times negative 5, which works out to be 1, negative 4. In this case, we end up getting x equal 1 and y equal to negative 4. You can actually check it in the equations, and you'll see that x minus y is indeed 5. 3x plus 2y is indeed negative 5. Alright? And lovely, and so you realize that x is equal to 1 and y is negative 4. So, what we need to remember, we must remember this now, Anytime you're given simultaneous equation, you must rewrite it in matrix form first. Ax equal to b. Then now, A is the coefficient matrix of the unknown. Step 2, you must find the A inverse. You must find A inverse. And then step 3 is you're going to solve for x and y using the unknown x is equal to A inverse times b. Alright? So you already know A inverse and you already know the matrix B, the result matrix. That will give you the unknown matrix X. Alright? So once you utilize these 3 steps, you'll be absolutely fine. So that's it. That's it on solving matrix equations. So stay tuned to CXC Math TV for more, as we'll cover more Csec mathematics topics. Alright, so make sure you keep on practicing and do have a blessed day.